This warm-up is just to name all the different pairs that you're familiar with, and then we'll give you the new names of things you're not familiar with. And so things that you should know are vertical angles. So Ingrid, give me a pair of vertical angles.
1 and 3.
Okay. All right, 1 and 3 is vertical angles, so that's, hey there. That's 1. How about Taz? Oh, wrong class.
Not here.
Oh, right class. Oh, look at Taz and Tate. You guys sit in the same chair. 3-letter names. Well, 3 and 4.
Oh.
I have no excuse. Okay. What's another set?
Vertical angles?
Vertical angles.
2 and 4.
2 and 4, right? Okay, Amy, what's another set?
1 and 3.
Got that one.
Oh, 5 and 7.
5 and 7, right? And then Allison, what's another set?
6 and 8.
6 and 8. Okay, so those are review. And what do we know about vertical angles are in their measures? They're congruent.
Yeah.
Right? We learned that. You guys actually learned that in 6th grade in M24. You had lots of little solving problems with that. Okay, so what is the other familiar term there? Max, what's the other familiar term there? Like of all the blue words here,
Oh,
linear pair is the other familiar term, right? So give me a linear pair.
2 and 3.
2 and 3 is an example, right? We're not going to do all of them because you guys, you know those. So linear pairs, are they congruent? What are they, Rebecca?
They add together to make 180 degrees.
So supplementary.
Yeah.
Supplementary and adjacent. But as far as measure values, they're supplementary. They are also adjacent. Okay, so the other terms are probably new to you, including the word transversal. So this T doesn't have to be T, but they'll talk about a transversal often. So a lot of times you'll see T. T for transversal. The transversal of a line, of a pair of lines, is just one line that crosses other lines. But, I mean, so it's not that, like, wow. But when I or the author or you are having a conversation with another person or trying to communicate something, you may hear, look at the parallel lines and the transversal. That way you're looking at the parallel lines as a group, and the transversal is the thing that crosses over along. So transversal is just a line that crosses other lines. So it's more to draw your attention to a section of the picture. Yeah, Jake. A transversal usually crosses a group of lines. To be honest with you, I don't think you wouldn't really talk about it if there's only 2 intersecting lines. So another picture of a transversal could be, even in this picture, that red line is the transversal of those other lines. It's just not a parallel line set. But we could say this red line traverses the other lines, but we're not going to worry about that right now. We're going to just look at these. Okay? Does that make sense?
Mm-hmm.
Okay. So, in reference to that, all of these words are defined in reference to that. You are not going to have to repeat or write definitions for the 5 remaining terms. But you have to know what they are if I'm asking you about them, or if you're reading about them, or if you have to draw a picture about them. So it's not like the first chapter where I'm going to ask you to write the definitions, but you need to know what they are so you can talk about them. So alternate exterior angles, this is the way, yeah. Pat.
I think that they're like 5 and 3.
Yeah, why do you think they're 5 and 3? You're right.
Because it makes when the transversal goes through, they're
and the two parallel lines on the outsides of the two parallel lines, there are 4 angles there.
Right.
And then the two alternate, so they're on alternate sides of the exterior ones.
Right.
And then they're on the same sides, and they're obviously on the same side exterior.
Everything's defined that way. So in reference to the transversal, which I just highlighted it, things that are on alternate sides of the transversal, that they would be like 5's on the left side and 3's on the right side. And then the exterior part is in reference, so the alternate part, let's do this like with color, is in reference to the transversal. The exterior part is in reference to the parallel lines. So they're alternate sides of the transversal, but they're exterior to the parallel lines. They're outside the parallel lines on opposite sides of the transversal. So 5 and 3 is one set. What's another set? Yeah, Josh.
2 and 8.
2 and 8's the other set.
And you would just be able to manipulate that for the interior angles, like 1 and 7.
Yeah, right? So if alternate exterior angles are on alternate sides of the yellow but outside of the blue, the alternate interior would be on alternate sides of the transversal interior to the blue. Which were what? Were they, Josh?
1 and 7 and 6 and 4.
Okay. And then I saw some questions. So let's put that down. 1 and 7, 6 and 4. So really, a lot of the next 2 days, first of all, this is a new part of the chapter that you're not going to be quizzed on. This is the second part of the chapter. But I'm also going to be gone tomorrow. So I'm doing notes for 2 sections. You're going to practice 2 sections on a worksheet tonight, and you're going to come back and go over questions and practice 2 sections in the book tomorrow. And then Monday we'll do a quiz in the first half of the chapter, because I don't want to give you the quiz while I'm gone. But with all that right there, I saw some hands up when I turned around. Are the questions answered? So we're okay with all that? Okay. So corresponding. Okay, so let's look at corresponding. The way I think of corresponding is just 2 angles that are in the same sort of relative position. So 2 corresponds to 6. They're just on the same side of the transversal and both above the parallel lines. So what's another?
1 and 5.
1 and 5? What do you think, guys? Yeah. Same side of the transversal below the parallel lines. Yeah, Tess.
Do they have to be on the same side of the transversal?
Yeah. And remember, most of the time when we give things like this names, we're just naming them so we could talk about them. You know, like it's easier to talk about a square than a parallelogram, 4 equal sides, 4 equal angles. It's just easier to say square. So it's easier for me to say, okay, look at the same on the left side of the yellow line and above the blue lines. That's just a lot of work, so we name things. So 2 and 6, 1 and 5, 3 and 7. Hey there, that's split apart. And then the last one, what was it? Yeah, 4 and 8. Okay, good. Same side interior, not much. So what does that mean? Same side of the transversal and interior to what?
Parallel lines.
So what is it, Carson? Same side
7
interior.
and 4.
7 and 4? What do you think? Yeah. Same side interior, 7 and 4. And Anna, what else? 6 and 1, right. Okay. And then the last one, Dylan, same side exterior?
Could be 3 and 8.
Yep. What else, Dylan? Right. Okay, so once you know the names of them, you want to know the properties. So, what was the same side exterior? 2 and 5. And you said 3 and 8, right? All right. So I'll put a little picture of that up on the website, just in case you need to see that. But the real question is, with all of that information, what is congruent to what? So first of all, with vertical angles, what do we know in general for vertical angles? Like angle 4 and 2, what do you know about it? They're congruent, right? We learned that in M24. You guys already knew that a month ago when we started the school year. And then we also learned, so we know vertical angles are congruent. How about Aki? How are linear pairs related? Like 2 and 3. What could you say about 2 and 3? They're supplementary, right? So 2 and 3 are supplementary, and then that makes 1 and 3 congruent, right? So 2 and 3 are supplementary, so they're a linear pair. Okay. So what do we know then, say about, I mean, just looking at that picture, what do you think's true about 3 and 7? The lines are parallel. Yeah, Josh. They have to be congruent, right? So these are called, what are 3 and 7? They're congruent. Starts with a C. They're corresponding angles. So corresponding angles, they're congruent. So what about alternate interior angles, Ethan? Give me an example of alternate interior angles in that picture.
1 and 7.
1 and 7. So what do you know about them from just the way I've marked it? When the lines are parallel, they're congruent. Okay? This is always when the lines are parallel. I'm loving how this is disappearing. It disappears every time I tap the other page. That's what's happening. So if the lines were not parallel, okay, if I drew another picture, and I call this like L3 and L4, and then I have a transversal. I can still have a transversal.
It wouldn't be congruent.
Yeah, but now the vertical angles are always congruent, okay? But if the lines are not parallel, you could see that the corresponding angle marked in black compared to this corresponding angle here marked in blue, they're not the same, right? I mean, I can trace it and move that purple angle in here. So if I asked you like a true-false question and said corresponding angles are congruent, sometimes, always, never, let's do that. Sometimes, when? When is it? When the lines are parallel, right? So if I said true, false, corresponding angles are congruent. False. Okay, corresponding angles of parallel lines are congruent. True. Okay, so some of these hold all the time. Some of these hold only when the lines are parallel. So we know 1 and 7 are alternate interior angles, they're congruent. So we also know that 7 is congruent to 5 because of vertical angles, right? And that means 8 must be equal to 4 because 5 and 8 add up to the same amount as 1 and 4. So that goes back to the fact that we already know corresponding angles are congruent, okay? And 6 and 8 are vertical. And so over here then, what do we know about alternate exterior angles? 2 and 8. Congruent or supplementary? Congruent, right? We already had these. Hey there. Alternate interiors were congruent. Same side exterior. 3 and
Oh, okay.
3 and 8.
3 and 8. So what are they? Supplementary, same side interior, supplementary, corresponding, congruent. Okay? So how are you going to use this in a problem? Tonight you're going to do a worksheet, and sometimes you'll have parallel lines and sometimes you won't. Okay, we just looked at an example with parallel lines, but when the lines are not parallel, then the only things that are true all the time are vertical angles are always congruent no matter what, and linear pairs are always supplementary. Okay, so you might have a problem tonight where you've got some angles and you have to use all the theorems you know so far, like triangle sum theorem, for example, to find all the missing angles. So like I know angle 4 is how much? 80, right? And angle 3 is 100. Okay, and angle 1 has to be 100. So the question is, can I find all the angles? Do I have enough information to find all the angles? 9 is 25 way down there. How's that going to help me, Jake?
Well, it's not numbered, but the vertical angle for 9 is 25, and then 7 is that's 4, and the angle that you just found.
Triangle sum theorem, right? So this adds to 5. That adds to 105. So 7 has to be 75. So is 70. So is this. 6 is 105. So that's an example of how you use some of the theorems you already know. Yeah.
Is the triangle sum theorem just like the angle, the total measure of all the angles in a triangle?
Sum to 180.
Alright.
Right. Okay. And then you might have something like, let's say, number 9, where you have symbols that tell you the lines are parallel. So now these are called what kind of angles? Corresponding, right? So there's lots of ways to do this. You actually did this in M24, some of it. Like you solved for vertical angles with matching cards that I made, unless you weren't here. So I know I can do lots of things here, but I'm going to just write on my picture, like I know that this is congruent to this, and these are congruent. So I'm going to set them equal. Solve for x. Does that make sense? So I would say 182 minus 4x is equal to 5x plus 2. And this is an example where that algebra is going to come back at you all year. Add 4x to both sides. And then subtract 2. Any questions? Remember that? So what do we have, Jossie? On the left.
180 degrees equals 9.
Right, 180 degrees equals 9x. So 20 is equal to x. That's not degrees, that's x. So then you can find the degree of the angle if you're asked, or in this case, you're just asked for x and y. So now I can find y, because I can plug my 20 into there. Okay? Get how that's applied? We're going to stop there. So that's the next 2 days.